Transcriptions. Okay. So I can recommend you this website. Very easy and use, in the many pictures with many clarifications. Some clarifications you could learn about patterns here. But today we will go. I would like to share actually my screen. I don't like such. Let me do this. Okay. Can I share it? No. No. Strange. Okay, one more time. So okay, I understand. So today's topic is to learn what is a JavaScript pattern, and we will take a look at their examples. Give me a second, I will share you. Okay, that's how I would like to. No, you shouldn't see for a full screen, right? Oh. Okay, anyway. So today's topic, we just discussed a little bit about JavaScript design patterns. We know what is it patterns, which we use it for them, and also discuss some templates, which might be helpful and useful for you. So basically, you could learn using some books. For example, this is the one of the book where you could read more about design patterns in JavaScript, how we can implement it using by the JavaScript language. But also, I recommend you to see this website also. This is in English, and there are a lot of examples there. This is totally free. Sometimes here you could see that they might recommend you to buy some books or recorded books. I'm talking about audio book. But anyway, all information is presented here also. If you will go to the main page, you could see that here a few chapters about design patterns, anti-patterns, refactoring tools, and UML, modeling languages. So you could use this website. This is like another source for you. Hope this is clarify your question. Okay, where is my presentation? Here, yeah. So basically, design patterns. For example, you maybe you know that sometimes we can face with a typical. We have not like this. I think that we might explain for what we need design patterns. This is to tell or to think about situation when we faced with a similar task. For example, we need to create animal which is called lion. This is task for example, for me, and for my colleagues was provided the task which is called creating class for not lions, for wolves, for example. They are both animals. They both have some characteristics. So in order to avoid repeating some examples, some similar codes, we might use using implementations which is some excuse me, I need to close the door. Give me a second, please. Okay, I'm here. So in order to avoid some repeating parts of code, we usually use some methods. We would like to use for classes, for example, which is called animals. And in animals, we will describe some basic tools for the animals, right? But for lions and wolves, we will add something like how they say something, their behavior, and so on. So, but if we will talk about general things, not about lions and animals, if you would like to talk about some behaviors, some basic things, how to easily can create something from scratch, and in order to avoid something too difficult thinking or discussing how we should do this task, we have some patterns. And patterns usually solve the problems. Here is written that pattern solves these problems millions and billions time in effective way. Why? Because problems in programming, software programming. Because when you trying to discuss something new with your team, you will see that in the result there are a lot of mistakes, for example, in codes, in performance, and so on, so on. But patterns, this is truly best tools which you can use effectively in your application. So what is a patterns? A patterns is a reusable solution which is solving a problem with a given context in software design. Pattern, this is like a template for how we solve the problems, ones that can be used in a few different situations. And patterns are proof solutions. And this is not only these patterns applicable not only for JavaScript, it's also using in abstractive way for C#, C++, and so on. So types of design patterns. There are a few types of design patterns. Here we will talk about creational, structural, and behavior. And we will take a look a bit later about them more closer. Creational design patterns deal with initialization and configuring classes and objects. Structural deal with decoupling interfaces and implementation of classes and objects, composing of classes or objects, and behavior deal with dynamical interactions amongst society of classes and objects, distribute responsibility. So we could see here that how to moment. Okay, so let's talk a little bit about models. In JavaScript, the model pattern is used to further emulate the concept of classes in such a way that we are able to include both public and private methods and variables inside a single object, thus shielding particular parts of the global scope. How we could do this? Model is a combination of two simple patterns, self-executing function and private variables and methods. For example, here, we could see the model object. A second. For example, let's take a look just a little bit closer. Here for model, we have the model object. This is a function, and providing for this function a few additional methods. increasing counter, reset counter. We can use these methods, just calling model dot name of methods, right? But for model constructor, we could see that here we're using prototypes, and using these methods, it's just a little bit, looks almost the same, but we might change some structures, and using model constructor just a little bit easier. So advantages and disadvantages of model patterns. So the advantages is support of private data, splitting the project into the logical blocks in order to reuse them. So what does it mean? It uses that you easily can use, for example, this model constructor, but also you can easily to add new functionality into your own classes, which will be subclasses. So, and disadvantages: ability to test private data, dependency need to be handled manually, and module structure organization modules, 6 modules. Let's talk about a little bit creational patterns. This is the first patterns which we will take a look. This is a singleton. Then we will discuss about factory a little bit, and patterns, fabric, and which is compare their differences. So singleton, where we can use them. If we would like to provide single instance of class, when you try to create another instance, the program should receive an item that has already been created. How we can use them? Just using model pattern. So here we have an example of singleton pattern. Here we could see that singleton pattern involves a single class which is responsible to create an object, while making sure that only single object gets created. This class provides a way to access its only object, which can be accessed directly without need to instant the object of the class. And how does it work? Usually, okay, we create in singleton classes. We have the constructors here. Let's just take a look here a little bit closer. So in the constructor, we have some variables which will be moment. A few variables we define in variables which we can use inside our classes, and few methods which is will be applicable and usable for us. So here is a set foo and set bar. And if we would like to call this to, so if we totally would like to compare these classes by creating new variables, for example, here is provided as singleton 1 and singleton 2 constant variables. So they are totally the same. But also don't forget that we might extend this these new variables and provide them just a little bit more information about extending. So if we would like to create more wider class from singleton pattern, it will be easier using such methods. So in this pattern provide a global point of access to the object. Using such pattern, we might share the state across the whole application. And easily use them into different types of application, just extending this class and providing a few additional methods which we need for our variables or new objects. So the advantages: control access to a single interface instance. Disadvantages: this is a global access, problem with testing, and possible often so here as a disadvantages, we have some the bad thing. This is we have a global access to these classes, and it might be some problem with the testing, especially if we call it in a different part of applications and try to add more options and methods to the class. So, and if we would like to talk about factory pattern, so I need 1 second, please. Some kind of issues with my microphone. Moment. I think should be better because. So can you hear me now?
Yeah, I can hear you.
Yeah, we can.
Okay, thanks. One more option. Second. Okay, so about the factory pattern. For example, so where we can use factory can provide a generic interface for creating objects, where we can specify the type of factory object we wish to be created, and how we can use them using the factory methods, which will select the appropriate constructor. So in factory pattern, we create object without exposing the creation logic to the client and refer to newly created object using a common interface. When we using them, if you would like to encapsulate a group of individual factories with a common goal, when we need to easily generate different interfaces of object depending on the environment we are in, when our object or company setup involves a high level of complexity, and if we need to separate the detail of implementation of a set of objects from their general usage. So this is something, how to say, factory very often use it in AngularJS, for example, but not only in AngularJS, but this was like a principle of AngularJS for using factory. Why? Because we just can easily identify some object, provide them default settings, and using factory we can we can separate them by common goals, and using these patterns, we just create more complicated, a little bit class, but more abstractive for more. In such ways, we might use them just a little bit in more ways. So what I can tell you about these patterns, I really recommend you, if you would like to understand how to use them just a little bit in deeper, to try to implement these classes by yourself and check them, how it works, all of these classes and methods, because usually you could face with them very often. So the examples. For example, here we would like to create new objects, provide them a few parameters, new parameters, and to check, is it object, number, string, and boolean. So this is one of the way how to build in factory. This is just default way how to create new object. And in this object was created constructor inside, where we can where was returned the boolean value true or false. So something like this. But what about car maker? This is a pattern constructor. For example, we can remember something about functions, right? We can provide some methods using prototype. So for example, here with the car maker, we provide some, to the car maker, we add some method which is called driver to the parent, and saying here that go, I have these doors. So it should like we have some common methods. So if we would like to create a factory, we provide here some new additional variables with a just give me a second. So here you could see the static factory methods. Here we are creating some type. We creating the variables new car, and for this new car variable, we will add some new classes, some new methods, new car maker, and provide. We would like to provide here just. And this new car will contain this method, which is drive, and using such templates, we could extend these methods, just telling that this car maker, for example, here should be provided additional information about doors, about so in this template just provided the doors, but we might add some additional information, not only about doors, about cars, about models, and so on, if it needed. But anyway, how to create these objects? Just carmaker.factory, providing here some parameters, and we can use these methods easily. So for example, this car maker was give me a second. So we created here, defined here the specific car makers, and depending on these car makers, yes, we can tell that about the drive. Is it in this car 4 doors or 2 doors, right? So that's how the factory template is working, just providing here some statistic factory methods, which is combine some common parts for compact or convertible car, and you could choose and combine all needed methods just for using some features in a car. So advantages and disadvantages allow you to make the code more flexible using factory and provides a single interface for creating objects. The disadvantage is difficult to add support for new types of objects. About fabric and abstract fabric, organizing code is going to save us from a lot of pain. Usually it's depend using the features of object-oriented programming, we can employ certain design patterns to achieve better readability, reduce redundancy, and create abstractions if needed. One such pattern is a factory pattern. The factory pattern is a type of object-oriented pattern which allows the DRY methodology. This is we will just a little bit later take a look at the different methodology. As the name suggested, objects instances are created by using a factory to make the required objects for us. So let's take a look at the very simple example of using factory pattern to assemble an alligator object. To do that, we first need to make factories that create the alligator fast for us. So, for example, here we have a class which is called tail factory, and inside there we have a constructor which is provide us some properties. For torso factory, we also have, so in the first class we have tail length, which we can provide using the constructor. Then for torso factory we have the color, and head factory provide us property which is called snout length. So now we create a class that acts as an intermediary between the actual factories classes and the user. And let's call this reptile part factory. And this factory will return us this depending on type, depend as factory which we need for. And let's go ahead and assemble the actual alligator for alligator now and use the reptile part factory to get the required part for us. So, for example, alligator properties, the object alligator properties have tail length, color, snout length, and depending on this, we creating into the object alligator some additional parameters, which is tails, torso, and head, and these values gets from the appropriate classes. How about we should store the factory classes in an object and call the required part factory by using the part we want as the key. First, we'd have to register the factories, and it's be as simple as we see on the screen. Then now after this, the abstract layers can call the factory like this. So just calling by types with providing the prototypes, and this approach is much cleaner and allows to expand our factories without affecting code in a reptile part factory. So what I recommend you to do when you will take a look at your design patterns, honestly, I don't know about what you will see in the homework, but definitely here you need to implement this factory and try to run them. So here, this factory is actually, this example is better than previous just more abstractive, and you need to implement them and run them, to provide new classes, to create new classes by yourself in order to understand how it usually works. And that's my recommendation. So I hear someone sounds. No questions? Okay. So let's go to the structural patterns. Here we will take a look at the few new patterns. So decorator, we will take a look, facet, and just making conclusions. So about the decorator, be honest, this is a very I faced with this method, with this pattern very often. This pattern allows a user add new functionality to the existing object without altering its structure. For example, here we have MacBook default classes, which contains a few methods which can provide as a cost, screen size, and if we would like use the decorator pattern, we just first so here what we are doing here, importing MacBook class and providing them our methods or our calculation sum methods. So for example, here in decorator, we have a memory, which is we would like to, for memory methods, we provide, so memory depends on the cost, right? So MacBook cost, we are defining variables for MacBook cost, and using this link, we just changing the function MacBook cost to the new values, to the new method, how it will be calculated. The same with engraving and insurance. So just depending on this, we just provide a decorator to the memory, engraving and insurance, and easily use this new class with a new cost. So when we would like to use this decorator pattern, if we need sharing to support a large number of objects that have part of their internal state in common, where the other part of state can vary, rather than subclasses, we add properties or methods to a base object, so it's a little more streamlined. If we need to modify existing systems where we wish to add additional features to objects without the need to heavily modify the underlying code using them. So let's go to the next slide. Facet. This is a pattern which is providing a convenient higher level interface to a larger body of code, hiding its true and underlying complexity. We can use them by creating a set of facet methods and joining them in one place. The advantages of such pattern is easily access to a complex system and resistance to change. Disadvantages of such method, this is it's not allow obvious what's going on in a certain method. Methods can be such methods used by facet pattern might be duplicated. So, for example, give me a second. So in page facet, this template, for to do something else, we might have a lot of methods. What we can do with a page, we can update this, we can update menu and do something else here, for example. Updating menu, what we need to do, we need to load data, resize column, and update counter, and set log. So, and how we can use them, for example, page facet, we might call with the method update menu. But usually what's like as the disadvantages, we might call these methods few times, so it might be you might face it during the code many times. So about the conclusions, about benefit of design patterns. Patterns can be easily reused. This is patterns makes a system in your project more transparent, because you could easily understand what's happening in some parts of code. Development. So patterns help improve developer communication, and patterns also help easy the transition to object-oriented technology. But unfortunately, patterns do not lead to direct code reuse. Teams might suffer from pattern overload. Patterns are validated by experience and discussions rather than by automated testing. And integrating patterns is a human intensive activity. So also the latest part of them. Give me a second. So we've discussed that we have a few some patterns which we take a look through the creational patterns and structural patterns. So now we just a little bit discuss about behavior patterns. and this. So strategy patterns, we create objects which represent various strategies, and context object whose behavior varies as per its strategy object. The strategy object changes the executing algorithm of the context object. And I would like to read this part, actually. Something happened with this presentation, usually. So when we would like to use it, when we need to define a family of algorithm, encapsulate each one and make them interchangeable, strategy lets the algorithm vary independently from clients that use it. So I would like to provide you just a bit more about the strategy information. So here, for example, I would like to share. So design patterns. And so, for example, on this website, you could see just a little bit more about creational design patterns. Singleton, this is like, basic, but unfortunately, we didn't discuss so prototype pattern, which you could see definitely often. About the strategy. So I would like to provide you some example. Give me a second how to show it to you. Let's take a look at the example. For example, we have few methods how we can go to the airports. So depending on this, not methods, we have a few transports how we can go to the airport. And depending on this transport, we might change or define some strategy. And using this strategy, we will go to the airport. So the traveler in this case, so with such easiest example, you might better to understand. So we changing something, we provided for this transport. So we have some options, we choosing these options, and depending on this option, we just doing what we planning to do. I'm not sure that it's a really good explanation, but these examples in these patterns, you should understand that you have some examples of code in this presentation, but generally they are more common, have some common explanation. And so you might combine them. So I recommend you to combine the presentation with this website, and you just can easily understand this. So for example, in this presentation, the example is so this strategy have execute methods where we have a throw error point. For example, depending on the strategy, this class. So what does it mean? Depending, we define some classes, which is greeting, polite greeting, and friendly greeting. And depending on this strategy, which we would like to use here, we just make greeting, and depend on this, we just have greetings, which might be just friendly, or say our friends, hey, Kate, for example, welcome and hello. So this how you can combine and using the strategy. So just providing some additional methods, creating more abstractive class and using them when you need it. Observer. This pattern is we using when the object in a system may subscribe to other objects and be notified by them when an event of interest occurs. And usually we using these patterns using JavaScript events. So here just a common structure, for example, structure of behavior. So what we should do with, for example, when we're clicking on a button or would like to, how to provide here the good example really about this pattern, we just can subscribe, unsubscribe, and we can, for example, notification. So if we would like to click, the best example on, I think this is if we would like to if we tell about some subscription for emails, for example, right? Maybe this is might be just a little bit easier. So you might subscribe to the email to some to giving some news from some website. You might unsubscribe, and also if you subscribe, you will see the notification on your email. So here, the most similar behavior. So when we build website here, in this example, in our application, when we build web application, you end up writing many event handlers. Event handlers are functions that will be notified when a certain event fires. And this notification optionally receive an event argument with detail about the event. For example, the X and Y position of the mouses at the click event. So basically, for example, notification might be, I don't know how to provide, unfortunately, the best example, but for example, if we twice click on the some button, we might we will receive some additional information that it was twice, and you twice click on the button, and it means that we need to unsubscribe. So something like this, depending on what we clicked, we're receiving some information, and using on this behavior, we doing something with our actions. Advantages of such method: this is a weakness, the relationship between objects, and it helps to simplify objects, but unfortunately, system is getting less transparent. So about the mediator. Mediator is a behavioral design pattern that lets you reduce chaotic dependencies between objects. the pattern restricted direct communication between the objects and forces them to collaborate only via a mediator object. So yeah, so this just sorry, one more second, please. Guys, one more minute, please. I'm so sorry, but just need a 5-minute break. Okay. It's left 1 hour. Let's do 5-minute break. Okay. Okay. So, okay, I'm back. So sorry about this, but urgent situation. So, about the mediator. Yeah, behavior design patterns lets us reuse chaotic dependencies between objects, and actually this pattern is helping us to create some relationship which easily be communicated with each other just using some abstractive mediator class. Yeah, actually, it seems like I've a little bit confused between observe example and mediator. So one more time about observe a design pattern. Observe design pattern usually solve the problem, which is, for example, a large monolithic design doesn't scale well. So and so because was creating new requirements. So not like this. So for example, we have a big project which is difficultly almost not scales, let's say like this. And because of this, we creating some because the system isn't scaling, creating some new requirements, for example, to the monitoring some graphic or monitoring requirements. And in order to avoid such issues, so we have observer patterns, and this is some kind of a way of notifying changes to a number of classes, and this observing design patterns, so defining one to many dependencies between object. So because of not like this, how to say, in order to change to change the state, one object to one object with his all related objects. So, and if this state will be checked, and his all related objects will be notified and updated automatically. So also, so here was just few other points how we can use this observe, but the main thing that this is a way how to notify and change something, right? With a mediator, the main idea of mediator pattern, this is define simplified communication between classes, and and provide them the way how they communicate with each other. So for example, if we would like to take a look at some example, simplest example, for example, let's design that the, how would call ATC, ATC, this is like a mediator. Oh, you know what? Let's go there. Here, I would remember that we have some, oh yeah, picture. So ATC, this is like a mediator. And this ATC providing us some communication between helicopters, airplanes, and other flying techniques. So that's how this mediator should work. For example, ATC should provide the information to the helicopter that nearest the airport there is a plane which is going to sorry, don't know this word. Feet, something like this. Boarding, maybe better to use boarding in this case. So the plane is going to the boarding. So the ATC provides a helicopter this information, and the helicopter, for example, isn't going to the ground. So, and in such ways, you know, safety is safety provided for all people who is in this in a helicopter and in a plane. That's, you know, better example how to explain how it works. So it's controlling, providing information, telling what should do in some times, but that's all. Not this pattern not providing some specific actions or methods, just communication between different types of objects. So here's some design patterns relationships, and let's discuss about development principles. Maybe you have heard something about this. Maybe you heard something about solid. I'm not sure that I see. Oh, okay. No notification in the chat. So maybe, so sometimes you could hear that such interesting idea that don't repeat yourself. This is a dry development principles, and these methods development principles actually telling us that we don't need to repeat. We don't need to repeat yourself and other. It means that don't need to repeat the similar code, right? It's better to create something unique. So what about keys? This is keeps it simple and stupid. So what does it mean? It means that if you can do something, if you could simplify something, you should do this. You must do this. Not please. The creator of this principle tell us that the code should be simple. The code shouldn't be so difficult. So it usually should be simple, and then it will be easier to you understand after sometimes your code. It should be. And also, it will be easier to understand your colleagues or new developers on your project what was implemented in your application. So let's talk about Solid a little bit. Usually, we can hear that these principles should know each developers, and that's why usually this question about dry keys, Yagni, and Solid, usually you could hear this question on the interview. And usually about the Solid principles, you might ask about each letter. So each letter in this principle means something. For example, as this is a single responsibility principles, these principles mean that so in general we could say that one class should be responsible only for one thing. So for example, animals should be responsible only for creating animal, right? You should set there how many legs, how many eyes animals should have, and it's all. Not about you couldn't add to animals some details about fish. So just animals, right? So the open-closed principles, which is O letter, this principle, how to say, so all classes, models, and functions should be open to the extending, but not for the changing. That's what it means. About the L, this is Liskov substitution principle. Actually, this is the most difficult topics, and usually I just try to simplify what does it mean, but you might take a look at the more detail with this principle, okay? So this principle means that all subclasses should be used as a no, not like this. All subclasses might be changed by their, not like, maybe I'm thinking about grammatic. I know it in Russian. Give me a second. Yeah, correct. So the subclasses be able to serve as a replacement for their subclasses. That's what it means. So the goal of this principle is that classes, which is how to say, the classes, subclasses, or just related classes, they might be used instead of their parents. So something like this, and they not be and these subclasses shouldn't be, so they might be using as like their parents, and also they not broken your application in such ways if they will be using as like a parents. So it means that they shouldn't broken your application, but they might be, these classes might be fully as much they can. So something like this. About the interface segregation principle, this principle is how to say, related, not related. Principle is the aim of this principle is to eliminate the disadvantages associated with the implementation of large interfaces, and this principle means that create highly specialized interface designed for specific clients. Clients shouldn't depend on interface they don't use. And about the last principle, about the principal dependency inversion. So the object, the dependency object should be abstraction, but not something specific. Something like this. It should understand. And so you might take a look about these principles more take a look at them by yourself. As I remember, they should be presented on this website too. Also, you could check them in Google, for example. But what I really recommend, you try to understand the Lipskovsky principle. Other, they are just simple. Actually, they don't have something special. That's for me. Okay, so about Yagni. You aren't gonna need it. So what does it mean? It means that if you don't need, not like this. So if in your requirements wasn't described something what you would like to implement, that you don't need to do this. You don't need to trying to implement this because your customer didn't pay for this, or it might be good function, but this function might not be used in your application. So if it's not required, that it's not needed. So, and the last, which is presented here, well, big design up front. Actually, this principle not. I'm not sure. I be honest. I didn't face with the questions about this principle, big design up front. So this is the approach in which the programs designed to be completed and perfected before the program's implementation is started. This is a principle usually associated with the waterfall model of software development. So that's why you might almost not see this. You might almost not face with this principle. So because right now, you know why it depends? Because right now, for example, if you will work with Scrum, you know, this is a flexible, Agile and Scrum, this is a flexible methodology. And usually Scrum means that there were requirements in the starting of the project, and you've implemented some part of the application of you realize something from your application first variant, for example, first version of your application. You've asked your users if they would like using such software, for example, with such combination of behavior and some additional options, and they provide you some feedbacks. And because of this feedback, for example, few users tell you, or for example, maybe 70% of users tell that they don't like such functionality and provide their steps how to improve this functionality. Usually you are changing your requirements, sometimes you might add some new functionality, remove some older functionality. So using Scrum methodology, the requirements usually change, and even sometimes you might face with the situation where you develop something, and in the end of the sprint, you hear that this change is cancelled by customer, and you will not send them to the production, something like this. So that's why big design up front, it's not good, because currently requirements is changing, and we don't have something which is which is designed on the first step, and then only like this you should implement something. So that's all for today. Oh, or 30 minutes. 30 minutes left. Stop to recording.